Good afternoon, class. Today we'll be looking at the properties of rhombuses, rectangles, and squares. Now, these shapes are kind of new, but they're really important. They're special parallelograms. So everything that we discussed in the last section is still true. Every single thing, like opposite sides being congruent, opposite angles being congruent, consecutive angles being supplementary, and the diagonals being bisected, are all still true for rhombuses, rectangles, and squares. But there's a few new things. So let's introduce these shapes first of all. First of all, a rhombus is a parallelogram with four congruent sides. So, if it has four congruent sides and it's a parallelogram, rhombus. A rectangle is a parallelogram with four right angles. That means if it's a parallelogram and it has four right angles, it's a rectangle. A parallelogram with four congruent sides and four right angles is a square. So these are three shapes. You should have known the two on the right, the rectangle and the square. The rhombus is kind of the new one, the one that you're not as familiar with because you don't see it as much, unless you're looking at squares. What we found out, though, is that with these shapes, we don't necessarily have to show it's a parallelogram. We actually only need to show what I have drawn on the bottom. If it has four congruent sides, it's always a rhombus. Of course, if it's a quadrilateral. If it's a quadrilateral and it has four congruent angles, four right angles, it's always a rectangle. If it is a quadrilateral with four right angles and four congruent sides, it's a square every single time. And those are the first three theorems of this section. It says a rhombus is a quadrilateral is a rhombus if and only if it has four congruent sides. The condition of four congruent sides is the only way it will ever be a rhombus. A quadrilateral is a rectangle if and only if it has four right angles. So four right angles is the condition of it being a rectangle. And last but not least, a square. Quadrilateral is a square if and only if it's both a rhombus and a rectangle. So you can think of a square as a unique rhombus or as a unique rectangle, one that satisfies the other. Alright, so let's just look at a few examples right away. For any square, ABCD, decide whether the statement is always, sometimes, or never true. Well, before I even look at the three options I have here, what I'd probably do is I draw a square ABCD. And I kind of fill in stuff that I know to be true. Alright, so I've drawn square ABCD. Now it's asked me, is segment AB the same length as segment BC? It's also asked me, is segment BC the same length as segment AD? And last but not least, it's asked me if measure of angle A is equal to measure of angle C. So I look at my shape. Alright, segment AB and segment BC, they're both sides. Yeah, that's definitely true, always. Alright, how about segment BC and segment AD? Well, both of those are sides again. Always. Because the square has four congruent sides. One question you might have had was, how do I know to draw A, B, C, D and not go A, B, C, D? You always go around either clockwise or counterclockwise when you're labeling. If you don't, you're going to mess yourself up. Alright, and the last one, measure of angle A equals measure of angle C. Measure of angle A, measure of angle, yeah, it's four right angles, so this is always going to be an always. So all three of these ended up being an always. There wasn't a sometimes or a never here. They were always. Let's look at the next example. Ooh, this is different. It says for any rectangle ABCD. Decide whether the statement is always, sometimes, or never true. So this time, it's going to change up a little bit. I look at the conditions that they want me to check at the end, but it really hasn't changed at all. Yeah, we changed one set of angles here. Instead of A and C, it's B and C. But otherwise, the side lengths are the same. Alright, so I marked everything I knew to be true. Now, I marked the four angles. As you can see, I went counterclockwise this time. I went A, B, C, D. The four angles are four right angles. And last but not least, I knew that these opposite sides were congruent because a rhombus, rectangle, and square is automatically a parallelogram. A rhombus and square has all four sides being the same, but a rectangle at least still has the opposite sides being the same. And that's how I knew to mark that. Now let's check what is true here. It says segment AB and segment BC are the same. Now, I know it's not always, so always has been crossed out. So if I had three choices here, always, sometimes, and never, always has just been crossed out. Now, are they restricted to never being the same length? Could I shorten segment BC here to be the same length as segment AB and it still be a rectangle? Yeah, because the only thing a rectangle has to be has four right angles. These two sides could be the same length. However, they don't have to be. They could, but they don't have to be. So I'm going to put sometimes. The example would be a square. If I would draw this real quick, and these were the same, it would still be a rectangle, but it's also a rhombus, so a square is the case where that's true. All right, let's look at BC and AD. BC and AD, always true. It's marked before I even looked at this here. It has to be always true because opposite sides of a parallelogram are congruent. All right, B and C, it's a rectangle. It's going to have all angles being the same, so this one's always true. All right, if you label it ahead of time, it makes this part easy. If you look at it as just words, it's tough. You're guessing, really. You need to draw a picture, or you need to be able to visualize, or you need to look for a picture in your book that matches up to it. If you don't, it's going to mess you up. All right, we still have a few more examples here that we have to go through. So let's look at the next one. What if I asked you to classify the special quadrilateral? Explain your reasoning. Whoa. Classify the special quadrilateral. That means when I look at this, I have to determine what for sure it is. All right, so I'm pretty sure I've copied this down correctly. Oh, this is definitely a rectangle. How do I know it? It has four congruent right angles. So I know it's a rectangle. How do I know? Four right angles. But I'm not sure if it's a square because the sides could be congruent. So I'm going to have to just verify real quick that the sides don't end up being the same value. So that means I have to find x and y. Now this is a parallelogram, so I know the opposite sides are congruent. If it's a rectangle, it's a parallelogram. So I'm going to do 4y plus 5. I'm going to set it equal to 2y plus 35. So let's get all the y's on one side. 2y plus 5 equals 35. Subtract 5 from both sides. 2y equals 30. Divided by 2, I get y to be 15. But I don't honestly care what y is. I want to plug it back in to see what the length I get is. If I plug y in here, 15 times 2 is 30. 30 plus 35 is 65. 15 times 4, 60, plus 5, 65. So these two lengths are 65. Now it's time to find x. Those two sides are congruent, so let's set them equal. X plus 31 equals 5x minus 9. Solve for x. 31 equals 4x minus 9. Add 9 to both sides. I get 4x to be 40. Divide by 4x to be 10. So let's plug it back in because I don't care about what x is. I want to know what value it has here. So 10 back in, I get 5 times 10 is 50, minus 9 is 41. 10 plus 31 is 41. Is this all four sides being congruent? No. So in this case, it's only a rectangle because it has four congruent angles. And it's not a square because it doesn't have four congruent sides. The next problem, I look. Well, I know it's definitely a rhombus. And the reason I know it's definitely a rhombus is because it has four congruent sides. Whew. But if this is a rhombus, it's automatically a parallelogram, which means opposite angles are congruent. So, just to be safe, I got to make sure I don't have four right angles. If even one of these angles is a right angle, all four ends up being. I know these two angles are congruent. 5y minus 5 degrees equals 4y plus 5 degrees. If I would somehow get it so this is a right angle, it's also a square. Or also a rectangle, which makes it a square. Because it's both. 5y minus 5 equals 4y plus 5. Just got rid of the parentheses and the degree sign. Don't need any more. Get all the y's on one side. Y minus 5 equals 5. Y equals 10. But I don't care what y is. I want to know what the angle is. Let's see. 10 in 10. 4 times 10 is 40 plus 5. This is 45 degrees. 5 times 10 minus 5 is 45 degrees. So if this is 45 degrees, this would end up being 135 degrees. So this ends up only being a rhombus because those angles weren't right angles. But I had to check just in case it was. Because if I would have found x and y and I found out that when I plugged them back in it would have caused it to be different, it could have been a different shape. This very well could have been a square. This very well could have been a square. Whether or not it's drawn that way, you have to verify that the values of y and x don't cause it to be something other than what shape it looks like. For instance, when I looked for an angle is rectangle, I had that right away. But I didn't know if it was a square until I did the math. Here, 4 congruent sides, rhombus right away. But I didn't know if it was just a rhombus until I did the math and said, yep, the angles are definitely not congruent. Not a right angle, so it's not a rectangle. That's the end of the first part. This is where you should take the time to do the first assignment of section 4. We're going into a different side of parallelograms, rhombus, rectangles, and squares. We're going to look at their diagonals. Whatever is true about a rhombus is automatically true about a square. Whatever is true about a rectangle is automatically true about a square. But what's true about a rhombus is not necessarily true about what's true about a rhombus is not necessarily true for a rectangle, and vice versa. So, theorem 8.11 and 8.12 says a parallelogram is a rhombus if and only if its diagonals are perpendicular. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. There's two different ways I can tell just by looking at the diagonals of a parallelogram if it is a rhombus. But here's the thing, it's not just if it's a quadrilateral, it's if it's a parallelogram. There's another shape called a kite that if the diagonals are perpendicular, it could be a kite. And a kite is nowhere near being a rhombus. Alright, so it's not good enough to just say, hey, if the diagonals are perpendicular, it's automatically a rhombus. No, it first has to satisfy the conditions of being a parallelogram, and then the diagonals being perpendicular. Then I can say rhombus. For the diagonals bisecting the angles, it first has to match the condition of being a parallelogram. There's another shape, I'm not sure what it is off the top of my head, but I'm betting it's also a kite again, but that'd be a guess, that has the diagonals being bisected, where it has the diagonals bisecting each angle, or pair of opposite angles. But let's see how we use, there's another theorem, but this one looks only at rectangles, and it looks at the diagonals of a rectangle. A parallelogram is a rectangle if and only if its diagonals are congruent. So, if I would put this into a diagram or a chart, I've just added that a parallelogram is a rectangle if and only if its diagonals are congruent. At this point, I'm going to sidetrack just a bit. There's going to be a chart we make later. In section 6, it might not be a bad idea to just quickly start it somewhere. You could put this wherever you think you're going to have chapter 6, or you could put this back when you get back from chapter 6, put this here. But I'm going to list everything true that I know about a quadrilateral. Well, a quadrilateral has 360 for the sum of the interior angles. It also has 360 for the sum of the exterior angles. It has 4 sides and angles. That's true about any quadrilateral. Now, anything that I draw below this quadrilateral, anything I draw with an arrow from the quadrilateral says it's true for that shape. There's going to be 2 other branches I draw here. This branch will be trapezoid, and this branch will be kite. But that's later. We'll get to those. The branch that we're going to look at now is parallelogram. And what I know to be true about a parallelogram, any parallelogram, is this: that opposite sides are both parallel and congruent. I know opposite angles are congruent. I know that diagonals bisect each other. And I know consecutive angles are supplementary. Whew, that's a lot of writing for the arm. Alright, and then in a parallelogram there's three shapes. There's what we call a rhombus, and there's what we call a rectangle. Alright, now a rhombus, the main thing that's neat about it is that it has four congruent sides. It's the only shape besides square that has four congruent sides. It has diagonals that are perpendicular. So remember the symbol for perpendicular is a upside down capital T. And diagonals bisect the angle. Or diagonals bisect the angles. Alright, and for a rectangle, it has four right angles. And it also has diagonals that are congruent. And last but not least is a square, which is a combination of the two. And the only thing that's unique about a square is that it has all the rest. So, what this is saying is whatever's true here is true here. Whatever's true here is true here. Whatever's true here is true here. And same thing here. If it's true here, it's true here. If it's true here, it's true here. Anywhere where you see an arrow pointing to the next shape, it means everything in this section is true for a rectangle. So instead of rewriting all of this for a rectangle, I'm going to remember that's true for a parallelogram, and I'm going to remember that a rectangle is a parallelogram. Now we do have more shapes over here that we're going to have to look at. You will want to leave yourself some room. But copy this down or memorize it, because you need to know all this information. This is basically the test right here. If you know this and know how to use it, you've got it. If you don't, that's where the struggles come in. Now, getting back to the section we're at, let's do a few examples using the diagonals. So, name each quadrilateral, parallelogram, rhombus, rectangle, and square for which the statement is true. Diagonals bisect each other. Let's look here. For number one, diagonals bisect each other. It's right here. Diagonals bisect each other falls under parallelogram. So the very top one, I'm going to say it's a parallelogram, it's a rectangle, it's a rhombus, and it's a square. Because if it's a parallelogram, it's also true for a rhombus. If it's a parallelogram, it's also true for a rectangle. If it's a parallelogram, it's also true for a square because of how it flows down. Alright, so the first one up, good. Next question, it says diagonals are congruent. So I looked through my chart. When are diagonals congruent? Right here, for rectangles. Diagonals are congruent are true for rectangles. And if it's true for a rectangle, it's true for a square. So, for a square and a rectangle, diagonals are congruent. Alright, the next question is diagonals intersect at a right angle. So look, diagonals intersect, diagonals, nope, diagonals, nope. Diagonals are perpendicular, intersect at a right angle. There we go. So it's a rhombus, which means it's also true for a square. And last but not least, the fourth question says diagonals bisect the angles. Diagonals bisect the angles. Diagonals bisect, nope, diagonals are congruent, nope, diagonals are, nope, oh, there we go, it's true for a rhombus, and it's true for a square. So, the first one is all of these right here. The second one is true just for the rectangles and squares, the next one is true for rhombus and squares, and the last one is also true for rhombus and squares. This chart will help you know which shape it's for. But this I have committed to my memory, and it helps me get to where I'm going sooner. If you don't have committed to memory, you're going to be relying a lot on this diagram. Okay? And we're going to be adding to this later. Next example. It's not going to be asking which shape is this true for. Now it's going to give you questions like, hey, how can we use this? It says the diagonals of rhombus ABCD intersect at point E. Given that measure of angle DCA is 72 degrees, find the indicated measures. So in this one, it's going to help me a lot to redraw the shape, because then I can label in everything I know. So in this case, how did I draw it? I can't remember off the top of my head. Let me look. A is in the upper left, B is in the upper right. So A, B, C, D, and E. Now I said angle DCA is 72. Wait a second, if that's 72 degrees, this is a rhombus. Rhombus. So the angles are bisected by the diagonal. Or wait, the diagonals bisect the angles? So that means if this is 72, this is 72. 72 degrees. And wait, these angles are congruent. The big angle and the big angle here are congruent because opposite angles of a parallelogram are congruent. So that means this angle has to be the same as this one, and it's also cut in half. So this ends up being 72 degrees also, and this ends up being 72 degrees also. Wait a second, this also intersects at a right angle because because diagonals of a rhombus intersect at a right angle. I think that's all I know for now. Let's see if I can use this information. Measure of angle BCA is the first thing they asked me. Well, measure of angle BCA, oh, I've already found that. That's 72 degrees. I just filled in some information and I've already got my first answer. What about the measure of angle BAC? Well, now I look for BAC. BAC, I've already filled it in. I knew it just by looking at it and using the information. I didn't have to be asked to go find it. I just went and found it. Measure of angle BEA. BEA. Right here. Oh wait, that's a right angle. So that's 90 degrees. It sure pays to do all that work ahead of time. Now all I have to do is copy it down from where I see it. Measure of angle BABC. Measure of angle ABC. Okay, now this is the one where I have to do a little bit of thinking, because I didn't do the work yet. ABC. This angle here and this angle here are supplementary, which means 72 plus x, because that angle has been bisected. So if I add all those angles together, because those two big angles are supplementary, 72 plus x equals 180. Solve for x. So 144 plus 2x equals 180. 2x equals 36. X equals 18. So each of these angles here are 18 degrees, which also would mean down here, both of these angles are 18 degrees. So measure of angle ABC, the big angle is 36 degrees. And last but not least, the measure of angle ABD. Measure of angle ABD, that's 18. So the basic idea I used here was, first of all, that this angle bisects, or this angle is bisected by the diagonal. I also use the idea that these angles are congruent because opposite angles are congruent, and also this is also bisected up here. So the big angle 144 cut in half is 72 and 72. I also use the idea that this is a right angle here because it intersects perpendicularly. And then I just filled in all the information I knew, and I solved until I had everything. I could have filled in all the angles. I could have said, hey, fill in all the angles here. I ended up doing that anyway, and then just pulling out the information I needed. Use the properties. Don't always just be looking, how do I know this angle? Just fill in what you know and go from there. One thing to note, look, 72 right angle 18, 72 right angle 18, 72 right angle 18, 72 right angle 18, and each hypotenuse is the same length. Angle, side, angle, angle, side, angle, angle, side, angle. You have 4 congruent triangles. Whenever you have a rhombus, you have 4 congruent triangles, and they all happen to be right triangles. When you have a rhombus, you have 4 congruent right triangles. Something neat. And example 6, it says the diagonals of rectangle ABCD intersect at E. Given that measure of angle DCA is 72, find the indicated measures. So we have the same issue as before, but now we're using different shapes. And we're essentially going to be asked to find the same measures, but let's try this and see what we get. Alright, so let's do some work here. The only angle they told me for sure was DCA, and we know that this here is 72 degrees. Wait a second. Here's a right angle. If this part of the right angle is 72, well, this here is 90 minus 72, or 18 degrees. Because the right angle minus 72 will be the left over. So this is 18 degrees. Ah, I see something else. If I would cover up this part right here, I see a right triangle right here. And this right triangle has this angle, and this angle all add up to 180. Well, 90 plus 72 plus blank equals 180. Well, it ends up being 18 when I do that. Or 90 minus 72 again. Well, if this is 18, that has to be 72. Alright, good so far. Now I look at this, and this is where it gets a little bit tricky. But the diagonals are congruent. Wait, the diagonals are congruent? That means when it bisects, it cuts it into 4 equal parts. And now, if I'm looking at just one specific triangle here, this one, I see that's isosceles. Wait, if that's isosceles, that means this angle and this angle are the same. This is 72 degrees. I see that these two on top, angle A and B from what you see now, isosceles. So that means this is congruent. If this is 72, this is 18. If this is 72, this is 18. What's x? Well, that's going to be 72 plus x equals 180. 72 plus 72 plus x, a triangle, all the angles add up to 180. 144 plus x equals 180. X is 36. So this angle here is 36. This is a straight angle or straight line. So this angle plus this angle have to equal 180. Well, x 36 plus what equals 180. So that means this is 144 and this here is 144. This is how I found all the information I needed. I found everything. Oops, I made a mistake here. This isn't 144, that's 36. I use the idea of looking at triangles here and finding out the rest. I look at this triangle or look at this triangle. I use the idea of isosceles and the angles across being congruent. There's a lot of different things I pulled over my hat here. But now that I have all the angles marked, at this point, it's pretty straightforward just matching them up. BCA is this angle right here. BCA, 18. So I put 18. BAC, angle up here, 72. BEA, this angle right here, 36. ABC, the big angle, which is a right angle, 90 degrees. ABD, this angle right here, 72 degrees. And there I go. And that's really all I have for you. You have to be able to fill in the angles here. You're playing pretty much an advanced game of find this angle. You're going to be pulling out everything pretty much that you know. You're going to use parallel lines, you're going to use alternate interior angles, consecutive interior angles. There's a lot of different things you can pull out here. But you have to be able to justify everything. Like for instance here, when I figured out that this was 18, I said block out this triangle here, 72 plus 90 plus 18 equals 180. You're going to be pulling out a lot of different tricks. Just make sure that you know what you're doing and you can justify it. Alright, I think that's all. Till next time.